Hi everybody, today we are continuing chapter 26, solving some examples. In this example, we have three power supplies and four resistances given by 12, 18, 15, 18 ohms outside and inside R1, R2 and R3. These are all 1 ohms and the power supplies are given as 12 volts, 6 volts here. So I1, I2 and I3, these currents are specified like that, and I2 is given 0.9 amperes. Our objective is to find what is R. So we would like to solve this. Okay, so the first thing we have to do is that if you look at this point, I1 is coming down and I2 is going to the right and I3 is leaving also here. So this is I3, this is I1. As you see, I1 is coming, I2 and I3 are leaving, so that I1 should be equal to I2 plus I3. Since I2 is given, this can be written as 0.9 plus I3. Okay, so we can use this. And from this, we can readily find I3 to be I1 minus 0.9. We will use this later. Now, instead of doing inside loops, let's do the outside loop, okay, the outside loop. So if we go this way, outside, we will start from this point, okay, from this point, and then go, come back to that point, writing all the voltages on outside. So it's outside loop now, Kirchhoff's rule. So it says that, Kirchhoff's rule says that all the voltages in a loop, when you add them up, you should get 0. So we start from epsilon 1, so I'm writing this theoretical and then I will put numerical values. Don't forget, I1 is now moving to the left here, I1, and here I2 is moving to the right, so let's just put this information. So I3 is going this way. So epsilon minus, because we enter from the positive side, is plus epsilon, minus, why? Because the current is going in reverse direction to our rotation, okay? I1 is this way, but we are rotating in the opposite direction. So minus I1, R1, and then outside this one, minus I3, R5, okay? Now we come here, it's minus again, I3, R3. Now we continue and enter from the positive side, it's plus 6 then, okay? Plus 6. And again, minus I3, in this case R4, I3, I4, because it's opposite. Now again, this opposite one, minus I1, R3, okay? Now we come to this one, and it's I1, R1 with a minus sign. And the sum, their sum should be equal to 0. So now if you put the numerical values, okay, 12 minus I1 times 12, okay, I1 is unknown here. And instead of I3, I'm now writing this for I3. So wherever I see I3, I will write I1 minus I2, 0.9, I1 minus 0.9 times R5, but R5 is just 18, okay? And then another I3, but for I3, again, I'm writing I1 minus 0.9, 1, okay? Because R3 is 1, plus 6, the power supply, minus, again, for I3, I write I1 minus 0.9 times R4, which is 15, and then the last two terms are given by minus I1 times 8 minus I1 times 1 equals 0. If you combine everything here, we can solve directly what I1 is. The solution for this is that I1 will be just 0.884 amperes. Okay, so the only unknown here is, as you see, I1. So you collect all the I1 terms and then put the constant to the other side of equal sign and then solve it. So this is basically what you get. And once you solved it, you can find I3 by just subtracting 0.9 from this number, which you will see that it will be negative, okay? So it's 0.884 minus 0.9, which gives you minus 0.016. So from this, we understand that given direction of I3 is wrong, so it should be in the opposite direction. So I3 should be in this direction. So this direction is wrong, but it must be in this direction. But the value is the same, of course. The value doesn't change, but the direction changes. But the rest are all positive. So we don't have any other difficulties with this. Okay, so from this now we will do another loop here. Okay, another loop inside to determine R. Either we can use the upper loop or lower loop. Okay, for the upper loop, okay, we can start from this point again and come back to that point again. Okay, so now I'm writing epsilon 1 because you enter from the plus side sign, minus because you're moving this way, but I1 is the other way. Don't forget. Minus, okay, I1 times R1 here, and then minus I2 in this case, because the current just jumped to I2 when you are moving this path, times R, which is the unknown resistance, minus I2, small r2 now, okay, and then plus epsilon 2, because you enter from the plus side, plus, it is 12 volts, and then minus again, because I1 is going down, but we're going in this direction, so don't forget the rotation direction, it's clockwise direction, minus, okay, minus I1 times R3, and then minus I1 R1 equals 0. We come back to this point again. So this is the loop equation for the upper loop. So if we just combine these, okay, what you get is that, so epsilon 1 is just 12 minus I1 and R1 are known, right? R1 is 12 and I1 is 0.884 times 12 minus I2, which is 0.9 times R, okay, minus I2 R2, but I2 is again 0.9 times R2 is just 1 ohm, okay, this small, and then plus 12 volts, this epsilon 2 is 12 volts, minus I1, which is 0.884 times I1 times R3, which is 8 times 8, okay, and then the last term is I1 times R1 plus 0.884 times R1, which is just 1, equals 0. So as you see here, the only thing which is not known is R, so you can solve R, and R turns out to be just 5 ohms. Okay, so this is the result. As you see, for this problem, because one of the current was given, we didn't have to do the other loop equation, because in that case, we would have to find also I2 to get another loop. We would use the lower part, for instance. In this case, the problem would be more complicated, but since I2 is given, I3 is readily found, and then by using this information, we can get the other current by just using one of the loop, which we chose, the outside loop, okay? We could have also chosen inside loop for this one, no problem. It would give us the result. But now, for getting the resistance which is unknown, okay? So you have to either use the upper loop or the lower loop. But we picked the upper loop. Starting from this point, we just put all the voltages and add them up and set to 0, and we were able to find the result easily. Okay, so this is the end of this example, and now you can ask me some questions.